All right, we are going to discuss the difference between valence electrons and core electrons. Valence electrons are electrons in an atom that exist in orbitals containing the highest value of n being the principal quantum number. It's these electrons, the valence electrons, that are going to determine the chemistry for the atom, the chemical properties. The core electrons are just non-valence electrons. Let's look at this, say, for the elements lithium and sodium. So if we take the element lithium, if I were going to draw the electronic configuration for lithium, I'd start here in the first period, and I know I'd be in the 1s subshell here, and I'll put in an electron for hydrogen and another electron for helium. And then I drop down to the second period, and again I'm in the s block here, so I'll stick in an electron now for lithium in the 2s. And we see now for lithium, the orbital with the highest value of n is 2. And so this electron here would be the valence electron for lithium. Whereas these two electrons here, in the 1s, those would be core electrons because they're not valence electrons. And it's really this outer electron, this single outer electron, that's going to determine many of the properties for the element lithium. If we do the same thing for sodium, we see we're going to do 1s, 2, and then we're going to drop down here, do 2 electrons in the 2s. Then we're going to move over here to the 2p, where we're going to have 3 orbitals, and we're going to stick in 6 electrons into those 3 orbitals. So I'm going to draw the 2p subshell, and I'm going to put in an electron for boron, carbon, nitrogen, oxygen, fluorine, and neon. And next, we'll have to drop down here to the 1, 2, 3s subshell and put 1 electron in for sodium. And so the valence electron in the sodium atom would be this single one right here. And then all of these would be core electrons for sodium. And we see that both lithium and sodium have a single valence electron. And that single valence electron is going to determine a lot about their chemical properties of those two particular elements. And we also notice that, sure enough, lithium and sodium both belong in the alkali metal family, which says they have similar chemical properties. And that's in large part because they both have a single valence electron. Let's try this for a non-metal. We just did it for these two metals. We'll try drawing the electronic configuration for, let's say, phosphorus, and we'll determine the core and the valence electrons for the element phosphorus, which is element number 15. So in this case, we're going to draw the 1s, the 2s. We're also going to need the 2p. We're going to need the 3s subshell, and we're going to need the 3p subshell to get in all 15 electrons for phosphorus. And we'll start to fill them in. Hydrogen, 1 for helium, 1 for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now we go to the 3s, sodium, magnesium. Then we go to the 3p, aluminum, silicon, phosphorus. Now what would the valence electrons be in phosphorus? We want to take the electrons in the atom that can exist in orbitals containing the highest value of n, the principal quantum number. We see n is 3 in the 3s, and n is 3 in the 3p, and so these electrons here would be the valence electrons for phosphorus. And we see that the valence electrons in phosphorus, the number of them is 1, 2, 3, 4, 5. Whereas all of these would be the core electrons for phosphorus. And it's really quite easy to determine the number of valence electrons in any of the main group elements. I like to say 1, 2, skip a few, 3, 4, 5, 6, 7, and 8, except for helium, which has 2. Now, what do I mean by that? Well, what I mean is all the elements in this column, in the alkali metals and hydrogen, all of these have 1 valence electron. All of the elements in beryllium's family, in the alkaline earth metals, all of these have 2 valence electrons. 1, 2, skip a few, so we're going to skip the transition elements. All the elements in boron's family have 3 valence electrons. All the elements in carbon's family have 4 valence electrons. All the elements in nitrogen's family have 5 valence electrons, which we just showed for phosphorus. 1, 2, 3, 4, 5. All the atoms in oxygen's family have 6 valence electrons. All the atoms in the halogens, fluorine, chlorine, bromine, iodine, and acetine, all of these have 7 valence electrons. And all the elements in the noble gases, except for helium, have 8 valence electrons. Of course, helium can only have electrons in the 1s shell, 1s subshell, I should say. Well, it's the first shell. This can only contain 2 electrons because it only has 2 electrons and it fills that 1s shell. So this has 2 valence electrons, while the rest of the noble gases have 8 valence electrons.